Most people think Docker containers are just lightweight virtual machines. They're not. A container doesn't virtualize hardware at all. It shares the host operating system's kernel directly, which is a fundamentally different thing. A Docker container is an isolated process running on your machine. That's it. It has its own file system, its own network, its own dependencies, but it's using the same operating system underneath as everything else on the host. The analogy that makes this click: think of shipping containers. Before standardized containers, every ship had to be repacked differently for every port. Docker does the same thing for software. It packages your application and everything it needs into a standard unit that runs the same way everywhere. Here's the scenario that every developer eventually lives through. You build something on your laptop, it works perfectly, you ship it to staging, and it breaks. The error doesn't make sense. After 2 hours, you find out. The server is running Python 3.8, your laptop has 3.11, and one dependency behaves differently between versions. This is the works on my machine problem, and it has killed more deployments than bad code has. Docker solves it by packaging your application alongside the exact runtime, libraries, and configuration it needs. The environment travels with the code. What runs locally runs in production. Teams move faster because they're not debugging environment drift, they're shipping features. When you run a Docker container, a few things happen in sequence. First, Docker looks for an image. A Docker image is a read-only template. Think of it as a blueprint. It's built from a file called a Docker file, which is just a text file listing instructions. Start from this base operating system, install these packages, copy these files, run this command. Each instruction in a Docker file creates a layer. Layers are cached and stacked on top of each other. If you change one line near the bottom of your Docker file, Docker only rebuilds from that point. That's why builds can be fast even for complex applications. When you actually run a container from an image, Docker uses two Linux kernel features to create isolation: namespaces and C groups. Namespaces are what make a container feel like its own separate machine. The container gets its own view of the process tree, its own network interfaces, its own file system mount. It can't see processes running outside it. C groups, control groups, limit how much CPU and memory a container can consume. So containers are isolated and resource constrained without any virtualized hardware in the middle. The Docker daemon, a background service, handles all of this. When you type docker run nginx, you're telling the daemon to pull the nginx image if it's not already local, create a container from it, apply namespaces and CE groups, and start the process. And if this is the kind of deep mechanism explanation you want for cloud infrastructure and DevOps fundamentals, Stack Future covers one concept like this every day. The container runs as a process on your host, lean, fast, and isolated. Say you're building a Node.js API. Your Docker file starts with from node 20 Alpine. That's a minimal Linux base with node 20 already installed. Then you add workdir, app, copy package.json, and package lock.json, run npm install, copy the rest of your source code, and end with cmd node server.js. You build it. Docker build tmyapi dot. Docker works through each layer, caches them, and produces an image. You run it. Docker run piat 3000 maya ap. The flag p3000 maps port 3000 inside the container to port 3000 on your machine. Because without that, the container's network namespace is completely separate. Your browser can't reach it. You hand that image to a colleague. They pull it and run the exact same Docker run command. Same node version, same dependencies, same behavior. No, it doesn't work on my machine. The image is the environment. That's containerization, working exactly as intended. A Docker container is an isolated process, not a mini virtual machine. It uses Linux namespaces for isolation and C groups for resource limits, sharing the host kernel directly. The image carries the environment, so the code behaves the same everywhere it runs. If this clicked for you, Docker Compose, how you run multiple containers together as a single application, is a natural next step. If this video was useful, a like helps the channel a lot.